For the most part, we understand how gravity works, right? What goes up must come down. But could gravity be a tool, or better yet, a key to the future? Welcome to the STEM. Let's talk about it. No matter where you are on Earth, you are being pulled to the center of our planet's core by a force called gravity. You may have heard of some dude named Isaac Newton. In 1687, he published a book called Philosophia Naturalis Principia Mathematica, which first presented his law of universal gravitation. The law states that masses, both big and small, are tugging against each other. And yes, that includes you. Your body is actually exerting a very small force on the Earth, hence pulling it towards you as it does to your body. That's how those zero-gravity flights work. It's when airplanes fly in a series of parabolas, giving the people inside about 30 seconds of zero gravity at a time. The pilots aren't flying to space or changing gravity in any way. They're just accelerating towards the ground at the same rate as gravity.
Here we go!
So why do mass and distance affect gravitational forces proportionally? Our solar system, for instance, was formed by celestial objects colliding with each other, while orbiting the largest mass in the system, our Sun. After most of the objects were shifted by the distortion of space around them, the system chose a general direction in which the planets orbit the Sun, giving us our solar system today. Here you're seeing Helen Tavera. She's a NASA SOFIA astronomer at the Fox Observatory and demonstrates how our solar system was formed. You can think of how mass distorts space like a trampoline. If you sat in the center and your friend rolled a ball onto the surface, the ball will go into orbit around you. Einstein's theory of relativity proves that massive objects, from planets to stars and black holes, distort the fabric of space and time. Yes, I said time. Relativity explains that time is relative. There is an effect called time dilation, which is how time either slows down or speeds up certain situations. Basically, time travel. In regards to gravity, time appears to move slower the closer you are to a massive object. Take the Great Pyramid of Giza. It weighs nearly 7 million tons. If you somehow stood inside the pyramid for a certain amount of time, you would have traveled into the future. You can see this through Robert E. Rayner's time longevity equation. It reveals how mass and distance have a direct correlation with time. But there are actually two variations of time dilation. There's the one affected by gravity, of course, and then there's velocity time dilation. Take the International Space Station, for example, or ISS. It orbits the Earth 250 miles over the surface, traveling over 17,000 miles per hour. Being far from the center of the Earth and moving through space at such a speed provides an opportunity for velocity time dilation to step in. In 2003, ISS science officer Edward Lu calculated that he aged 0.007 seconds less than everyone else on Earth, after just spending 6 months in space. The European Space Agency is currently working on the Atomic Clock Ensemble in Space project, or ACES for short. The mission, planned to launch in 2018, will attach an atomic clock to the ISS. It will be used to compare space-to-ground time dilation accurately for over a year. Hopefully soon, we'll get a better understanding of what time really is. With that said, yes, we can in fact use relativity to time travel, only into the future, of course. But whether it's building a giant pyramid or traveling through space at the speed of light, let us know in the comments how you'd build a potential time machine. Remember to hit the like button below, subscribe to DOG Studios, and check out Spinnaker Television for future episodes. Thank you for watching. We'll see you next time on The STEM.